wanted to show you how you can use one of the online calculators that I've linked in OpenLMS to save you from having to do some of the more complicated formula calculations that are included in the book. First, I'll show you how to get to that link. So I've already signed into OpenLMS, and I scrolled down to where our Unit 3 assignments are listed. And here we have the link for financial calculations. So we click that link. And then the annuity solver, or the time value of money solver, is the second link. And when you click that link, you just get a little pop-up box. So in this pop-up box, these are all the values that you would need to fill numbers in for or make choices about. First, the number of payment periods in the term of the annuity. This is typically the number of years times the number of payments you make each year. I% is the annual interest rate as a percent. You do not have to change it to a decimal in this calculator. The previous value is the amount of money that's in the account when you start to make payments. The payment is how much you're going to deposit every pay period. And the future value is what the account will be worth at the end of the term. You also have options for how often you make payments, either annually, semi-annually, quarterly, monthly, weekly, daily, and how often the interest is compounded. And you have all of those same choices. You can also choose whether the payment is made at the end of each period or at the beginning of each period. In most cases, unless the book specifically says otherwise, you can just leave that set to end of the period. So let's do an example. So we're going to try to make payments into an account that earns 2.5% APR for compounded monthly for 10 years, and we're going to make monthly payments. And we want to know what the future of monthly payments of $25. We want to know what that future value will be on that account. So the first thing we need to know is how many payments we're going to make. Since it's 10 years of monthly payments, that's 12 times 10, or 120. Our interest rate is 2.5%, and it's compounded monthly. So we'll leave that C compoundings per year at 12. The previous value is 0 because we don't already have money in the account. We're just starting this. Our payments are going to be $25 a month. And then our future value will tell us what and we're making 12 payments per month. So we're going to leave that as 12 as well. And the future value is what we want to calculate. So we click that solve. And you notice that it gives us $3,404.30. Don't worry about the fact that it's negative. The calculator uses the negatives in various combinations along the previous value, payment, and future values. I'm going to mention that in one example in just a minute. But for the most part, you don't have to worry about whether it comes up negative or not. Now, suppose that we know that we want to have $5,000 in the account at the end of 10 years. And we want to know what payments we would need to make in order to do that. Well, what we can do is change this last amount to $5,000. We're going to leave previous value because we're not putting in any money to start with. And we're going to make our payments at the end of each period. So we just have to click solve for the payment amount. And we see that we would actually need to deposit $36.72 at the end of each month in order to have $5,000 at the end of 10 years. So basically, when you fill in 4 of the 5 boxes here, you can click solve for the 5th one, and it'll fill in the appropriate amount. These are all drop-down menus, so you just have to make choices there. To give you one last example, we're going to try to figure out, suppose that we could only actually deposit $25 a month, but we want to have $5,000 in the account at the end. I'm going to leave that $5,000 in there. I'm going to put $25 in here, and I'm going to click solve. And notice that it says that our initial payment needs to be $1,243.06. So if I were to deposit that much in the account today, and then continue to deposit $25 at the end of each month, at the end of 10 years, I would be able to take out that $5,000 balance at the end. And that's what you have to think about with the arrangement of the signs. Usually, if you set the future value to be negative or 0, that's going to be the one that's going to set you up with the most correct, easiest way to put in the additional information. We're going to be using, you can also use this calculator to help you determine the payment of a car loan, because that, again, is just a payment. It's just an annuity. What you would do in that case is put the present value of the loan here and make sure you have the future value set to 0. And that will allow you to calculate the payments. So for example, if I'm buying a $30,000 car and I'm going to make payments on it, monthly payments for 5 years, that's 60 payments. And we'll stay with the 2.5% interest. So our loan amount was $30,000. We want the future value to be 0. In other words, we want to pay off the whole loan. So we can click solve, and our monthly payments would be $532.42. So these are some ways that you could use that time value of money or annuity solver to help you solve some of the problems that involve more complicated formulas in our textbook.